ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः. Okay, Swagatam. Welcome everyone. Session 17. Today we are going to start the topics on Nakshatra Vidya. So, um, Namaste, Gurupriya Chaitanya Mahodaya. Are you back in Parani?
No.
You're still at IIT?
Yes.
Yes. Okay, very good. Yeah, thank you for accommodating our class while you're traveling. Okay, I think you can take it away whenever you're set
Yeah.
up. Yeah, we can see your screen.
Whenever we do the Nakshatra Vidya sessions, we begin with an invocation. He Vishnu nihitam kritsnam jagat tvayeva karane jyotisham jyotishe tasmai namo narayanayate. As tremendous has been the sessions on Indian mathematics, Indian astronomy too is a very, very ancient knowledge domain. And one among the Vedangas in itself is completely dedicated to astronomy, and that is Jyotisha. We already saw that there is Shiksha, Kalpa, Vyakarana, Nirukta, Chandas, and Jyotisha. All these 6 Shadangas, that is the Shad Vedangas. Among them, we saw from the Kalpa Sulba Sutras, right? From the Kalpa Sutras, there are the Sulba Sutras that we already saw. We also saw a bit of Chanda Shastra, a couple of examples from them. Now we are going into Jyotisham. Jyotisha is a completely wonderful, very robust frameworks of observations and calculations that they have built. Let us try to get a glimpse of that in this course. In the ancient, India's most ancient text when it comes to Vedanga Jyotisha is dated back to 1400 BCE. This is earlier than the Western scholars dating the Sulba Sutras. Sulba Sutras are dated to 800 BCE. Whereas the Vedanga Jyotisha is dated even, prior to that, more than 600 years prior to that. So these datings, as I've said, and do not get into the trap of dating things. It is best that we leave one host of people debating about it. I'm sure there are some important voices that we must support there. However, the knowledge domain itself, is very, very fascinating. One should not get lost in the semantics of dating alone. So here we see in Lagada Vedanga Jyotishas, one among the invocatory verses, he says, Yatha Shikha Mayuranam Naganam Manayo Yatha Tadvad Vedanga Shastranam Jyotisham Murdhani Sthitam. He says. So he says, just like the Shikha of Mayura, unlike the money in Nagas, as you all well know, get formed over a long time of not using the poison, not using the venom in them. Having not used it for a long time, that crystallizes into Ratnamanis. So Naganam Manayo Yatha. So like how, the crestwell of a peacock or the serpent's gems, form as a rare occurrences and occurrences of great maturity, so does the science of astronomy stand tall, right, at the head of the sciences related to the Vedas, is what he says here. he's trying to convey that here. Some people also have a reading that Ganitam Murdhani Sthitam. Some people say Jyotisham Murdhani Sthitam. But we see in many of the Lagada Vedanga Jyotisha texts, it is Jyotisham Murdhani Sthitam that is there. So the science of astronomy as such, Jyotisha, has fascinated humans from a very, very ancient time. Even now, when we look up the skies, it's vast, it's inspiring. Uh, Hopefully, this course will help us, track a bit of what we must look at in the skies and our Indian calendar. It has certainly evoked a lot of notions in various civilizations looking up to the sky. And if you look at the Indian astronomical tradition, it is very, very ancient. It has evolved continuously, at least from the Vedanga Jyotisha period, right? That is 1400 BCE to all the way up to Siddhanta Darpana in 1899 CE. So this spans more than at least 3 millennia as of the Western Indologists themselves. So the knowledge of astronomy is still a living tradition because it is integral part of the social and religious life in the Indian ethos. And in India, one can find examples of astronomical ideas all the way from rock art, megalithic structures, to mantras in the Vedas describing certain astronomical phenomena, not just in the Vedas, in the Puranas, in the Itihasas, and so on, to megaliths and archaeoastronomy, building wonderful, temple architecture that are aligned to various astronomical phenomena, then to all the way to computational astronomy described in the numerous manuscripts, right? Even all the way to Savai Jai Singh's large observatories and so on. If you look at the classical astronomical sciences, Jyotisha, it can be broadly divided into two. One is the Ganita Jyotisha, another is the Phalita Jyotisha. That's why we are naming the subdomain Nakshatra Vidya, so that there is there is not any confusion regarding what we are going to deal with. We are going to deal with mainly the Ganita Jyotisha part and not the Phalita Jyotisha part. Phalita Jyotisha are predictive sciences, and it has played a very phenomenal role in India and continues to play a very important role. Within the context of our sessions, we may not be able to dedicate much time to that. What we must appreciate is that predictive sciences have been guiding humanity for a long time. Even now, you got to rely on various predictive models to figure out what you would like to do, to help you, aid you in strategic decision making, and so on. However, we will focus mainly on Ganita Jyotisha during this course, and we'll focus on the astronomical division of Jyotisha, which is given a great importance, and the primary objective is said to be Dik Desha Kala Nirnayam iti Jyotisham, or Dik Desha Kala Jnanam iti Jyotisham. So it is said that Dik, Desha, and Kala, to perfectly, to as accurately as possible, deduce the Dik directions, right? And then the Desha, your location, and the Kala, and the equation of time as a function of various celestial objects, not as an arithmetic counter, right? So Dik Desha Kala Jnanam iti Jyotisham. It is given great importance for fixing the date and time of various socio-religious cultural events. Thereby, like I said in mathematics, there was an urge to build perfect geometry, to build better things for our socio-religious spiritual purposes. So too, in the astronomy, in the Ganita Jyotisha, in Nakshatra Vidya, we see this urge to become more and more accurate, to become more and more profound in our calculations. Again, we can look at this in three eras, like we have looked at mathematics in three eras. One is the pre-Siddhantic era, Siddhantic era, and the post-Siddhantic era. So there were very ancient texts called Siddhantas. I will try to help you understand some terminology here in this class. What is the Siddhanta? We will come to understand it. Many studies dated back to 2500 BCE, as this Siddhantic, pre-Siddhantic era, the Vedic era. Then there is the Siddhantic era, then the post-Siddhantic era. As such, it is considered that there were 18 schools of Siddhanta. in the tradition of astronomy. However, only 5 were remnant by the time it was 5th century CE in itself. So Varahamira compiled all the 5 remaining extant schools of Siddhantas into a text called the Pancha Siddhantika. Somewhere here, yeah, Pancha Siddhantika. So this Pancha Siddhantika is a phenomenal text, and it sort of captured all the different schools and the models that were existent at that point in time. For example, we are just now writing some among the earliest known linear expressions in Vedanga Jyotisha as a paper, and we are trying to bring out how they connect to the Pancha Siddhanta tradition. How are their similar equations? How have these equations evolved over time? That's our current. Just 15 minutes back, also we were just authoring that paper. So this Siddhantic era has its pre-Siddhantic era has its own important feats that it has achieved. A lot of details to it, which I don't want to go into, and then sort of take away the essence of understanding the tattva of the knowledge. However, there were different calendrical systems at that point in time. There was a yuga meant in the pre-Siddhantic era. Yuga meant 5 years. It was to tally certain cycles, astronomical cycles. It went on like that, right? So there are various aspects, right? Then the Siddhantic era helps you understand Yuga very carefully as the Yujjantiti Yuga. When all the planets align together, okay, when all the planets align together on their circular path, with minimum deviation from each other, then we call that period a birth of another Yuga. And based on that, various Siddhantic calculations were made. Today, as what we understand as the period of Kalpa, and from Kalpa, what do we understand as various Mahayugas? From Kalpa, what we understand as Manvantras, and then Mahayugas, and the ratio of the 4:3 2:1 in the time periods with respect to the Mahayugas. Where we talk about 4.32 million years sum total put together as a Mahayuga, which is split in the ratio of 4:3 2:1 across all the yugas. All this comes out of an astronomical basis. It does not come only out of a Puranic basis. It comes out of a certain circulatory motion when they will align, at what periods, what intervals will they align, and so on. So that is the Siddhantic era. Then the post-Siddhantic era, or the medieval era, where calculations were much more advanced, as math had, where we already saw the birth of calculus had all happened. A lot of trigonometry had happened by this time, right? And so the kind of computations that we were doing were extremely accurate, and a lot of puzzles. Most classical texts used to have something called the Dasha Prashna in them, where knowing one or two parameters, how do you deduce every other parameter? So these were all very, very interesting things that happened in the post-Siddhantic era. I'll go through these eras. I'll help you tell some major classifications of text that is there in Jyotishas in the times in this session in further slides. So astronomy found in Vedic Samhitas, Brahmanas, they all show India's roots, this long run, running pursuit for excellence in Jyotisha. And for the performance of Vedic sacrifices at the times prescribed by Shastras, it was essential to have accurate knowledge of the science of time. Astronomy seems to have centered around the sun and moon, and its aim was to study the natural divisions of time caused by them, by their motion and the uniqueness in their motion and the periodicities and the kind of circular alignment that they come together over time. So days, months, seasons, years, all these, and with special attention to occurrences of new moons, full moons, accurately finding the instant of the, complete angular separation between the sun and moon, understanding equinoctial and solstitial days. We see that all this has been prevalent by the time of the Vedic times themselves. For example, the moon is called Surya Rashmi in the Taittiriya Samhita. It means one which shines by the sunlight, which suggests that scholars could have deemed that the moon was not self-illumined, a self-illumined celestial body. It is not a self-illumined celestial body. The dependence of moon's phases on its elongation from the sun is also implicit in Shatapada Brahmana, where the moon's path was divided into earlier 28 then later 27 equal parts, because moon takes about 27.33 days to traverse the Bhachakra. What's called the Bhachakra, etc. We'll see. The Taittiriya Brahmana also gives the names of 28 nakshatras along with Abhijit as one among the nakshatra, which is not there as part of the 27 nakshatra system right now. The Shatapada Brahmana gives the 27 nakshatras and the 27 Upanakshatras as well. So the constellations other than nakshatras that were well known in Rig Veda are Rikshas. Rikshas are the great and little bear that we see close to the northern pole. And then the two divine dogs, Canis major, Canis minor, closer to the southern pole. And the Argo Nav is the heavenly boat. Ursa major is Sapta Rishi Mandala, as we know in the Shatapada Brahmana, and the Tandya Brahmana. In Aitreya Brahmana, the constellations of Mriga or deer or the Orion, a very visible, highly visible, sort of fascinating constellation is Orion. Orion, Mriga, which is not part of the Rashi Chakra Mandala, but it is a very visible constellation. Similarly, Sirius is also the star Sirius is Mriga Vyadha, where this, it's a very, very, very visible cluster. The Sirius is huge mega cluster it is. Similarly, meteors were called Vulka and comets were called Dhumaketu in the Atharva Veda. Similarly, eclipses have been mentioned and described as caused by Swarbhanu or Rahu. Then the Rig Veda describes an eclipse of the sun as brought about by Swarbhanu. Like that, there are these aspects. So the Vedanga Jyotisha, other than the Vedas having all these astronomical data, the earliest known Hindu work dealing exclusively with astronomy is Vedanga Jyotisha. It comes in two recensions. One is the Rigvedic recension and the Yajurveda recension. One is called Archa Jyotisha, another is called the Yajusha Jyotisha. Right, their verses they clearly give India's calendrical system and an account of months, years, day divisions, all the foundations of the Panchanga, the Shad Ritus and the Ayanas. All these are given in the, and there is a 5 solar year cycle in which they try to reconsolidate various calculations and so on. And the author of Vedanga Jyotisha is traditionally identified as Lagada Maharishi, a great sage and scholar. However, precise details about his life and times largely remain unknown. So if we look at this timeline, okay, I earlier, in math also I introduced a set of Indian mathematicians that we should think about, know about in the introductory class. So too, an ode to our Rishi Rina, at least we must know a handful of, hand and leg, all toes, 20 plus Indian astronomers, at least we should know. Otherwise, we are just, we just know the few oft repeated names. So we see the Lagadha, Lagada Maharishi has given us the Vedanga Jyotisha. Then Vriddha Garga has given us the Vriddha Garga Samhita, in which the motion of Agastya Maharishi, many things, many phenomena are well studied in it. A good portion of it also deals with the Samhita Hora, and it also deals with a bit of predictive sciences. Right? A good portion of it deals with predictive sciences. Then, of course, the Shulbakara or Sulba Sutras, also need some time and space computation, directional computation. Then Vararuchi's Chandra Vakyas in 4th century CE, using the Katapayadi system, the celestial longitude of moon has been encoded in Chandra Vakyas, in beautiful Vakyas, which have some meaningful verses in them, and also at the same time give us the degrees, arc minutes, arc seconds value of the moon's longitude in these sayings of worldly wisdom encoded in the Katapayadi number system. Which means by then itself we were, if you look at the Vararuchi Chandravakya and make computations, it is accurate to arc seconds. Might be error of, it's definitely accurate arc minutes, error in the arc seconds happens there in the Vararuchis if you take the Chandravakya values. Then when we look at Aryabhatta 1, he has given us two things, Aryabhatiya and the Aryabhata Siddhanta. The Aryabhata Siddhanta is quoted by many, however, the full text in itself is not available. Then Varaha Mihra in the 505 CE, he has given us the Pancha Siddhantika, Brahmasputa Siddhanta, Khandakadyaka. All these, Varaha Mihra has given us Pancha Siddhantika, Brihat Samhita, Brihat Jataka, and other such texts. The Pancha Siddhantika, as I said, he compiles the 5 Siddhantas of those times. So we can broadly classify the astronomical texts into 3 layers. Okay, this is something very carefully we must understand. One is the class of text called the Siddhanta text. The class of text called the Siddhanta text, they deal with huge time scales. They deal with planetary alignment, computations when it which goes over many eons. Those are the Siddhanta texts. After Siddhanta text come the Tantra text. Tantra texts help you achieve within the Yuga. It helps you achieve various calculations. And Tantra texts typically mean algorithms. They are a book of various yuktis, calculative algorithms. These are all some Tantra texts, right? And after that comes the Karana texts. Okay. Very interestingly, I have them all here, I think. This is a, let me just stop sharing for a minute. You see, so this is a Tantra text and this is a Karana text. So the Tantra text deals with various algorithms. Okay, this cover design I got to do, and here you see this is a model, which is though geocentric, where the sun revolves around the earth and the Chandra revolves around the earth. All the other celestial objects revolve around the sun. Okay, this was Nilakanta Somayaji's Tantra Sangraha. These are Tantra texts. Tantra texts work extensively in bringing out various algorithms. Okay, various algorithms. They will have various derivations and so on. Nuanced algorithms that every Panchanga maker need not know. So they were built something called the Karana text. Karana texts deal with more localization, accurate to a few 2-3 centuries. The Karana texts were used for principal Panchanga making. Based on the Karana text, you could create certain vakyas, you could create certain methods, and thereby build easily some Panchanga. So the Panchanga makers did not know all these aspects. To give you an upamana, see, the people who assemble your Apple iPhones and Foxconn did not know all the sciences behind the entire, the nanosciences behind the semiconductor industry, right? So something is modular, something is done at a certain scale. Then somebody else brings that science down to an applicational scale. Then that is further brought down to another applicational scale. And finally, when a Panchanga makers assemble it, Panchanga makers are typically like the factory producing, units where they have assembled various components. That also requires expertise. It does not, it's not devoid of any expertise, right? But to make a gadget work requires expertise, right? Like that, they assemble the entire Panchanga for us. But for them, various classical astronomers have worked at various layers to create various texts that would allow them to build finally the Panchangas. So we have Brahmagupta's Brahmasputa Siddhanta, Khandakadyaka. Then in 629, we have Bhaskara one's Mahabhaskariya, Lahu Bhaskariya. Then we have Haridatta's Grahachara Nibandha. So this Haridatta's Grahachara Nibandha only deals with circular motion and periodicities of mega conjunctions. all combinatorics of conjunctions between different planets and different, so computing their instantaneous velocity, tatkalika gati, which means you should do a bit of rate of difference and rate of motion and so on. So there is Haridatta's Grahacharana Nibandha. Then Devacharya's Karana Ratna, one of the earliest Karana texts for helping others simplify the calculations. Then Lalla Sishyadhi Vriddhita Tantra. What a beautiful name. So Lalla said that, so Sishyasya Dhihi, for the intellect of the Sishya to grow. Here are some algorithms you must study. Right today, these are the guys who name. Today we name our things like the Complete Idiot's Guide to something, right? Or we say Head Start. What was the they were very famous Java books, Head First or Head Start series, or I forgot what their names were. So like that, different people made different combinations, different kinds of compositions to help us understand various deal with various aspects. So Govinda Swamin, the commentary on Mahabhaskariya. Similarly, Prithudaga Swamin, Vasana Bhashya, Brahmasputa Siddhanta, without which these people bring out worked out examples, without which we can't understand, what are all the cases, when all will it work, what won't work, etc. Then the Vateshwara Siddhanta, he was trying to create a new Siddhanta by himself. Then Manjula's Laghu Manasa, again we will bring out various wonderful, trigonometrical aspects in Laghu Manasa. Very, very, very interesting things he has done in Laghu Manasa. So the fourth sign will be 4 degree 44. Seventh sign will be 7 degree something. So he would play around with numbers massively to help computations in the Manjula is also called Munjala sometimes, and his work Laghu Manasa is very, very famous. Yet to become really famous, it's famous within the astronomical tradition, as others keep quoting them in the ancient texts. Then Aryabhatta too wrote the Mahasiddhanta. Sripati Siddhanta Shekara, Udaya Divakara, who wrote the Sundari on Laghu Bhaskariya. Bhaskara too wrote the Siddhanta Shiromani. Madhava's Venvaroha is one among the few existing texts that we have of Madhava, who gave us the infinite series we saw. Then Nilakanta Somayaji's Tantra Sangraha. Then Ganesha Devagna's Grahalaghavam. Grahalaghavam is an amazing text. So it comes to defy trigonometry. If can we do all of astronomy without trigonometry? Is this only sole objective of Ganesha Devagna and this entire school that follows him? Right? Ganesha Devagna, Krishna Devagna, Mallari, whoever follows him, they create phenomenal works where you can do all of astronomy without knowing a thing about trigonometry. This is all like truly great human feats. Then Nityananda Sarva Siddhanta Raja. So Nityananda, for example, in the Mughal period, he was a very, very famous Indian astronomer. So he tried to help the Persian astronomers understand our models well. He tried to create Sanskrit texts that capture the Persian calculations in Persian astronomy as well, that is the Arabic astronomy as well. And he also presented wonderful Indian texts, especially something called the Sarva Siddhanta Raja, where sine of alpha plus beta, sine of alpha minus beta, all these trigonometric relations, many things that we study till grade 12 are all there. Then the Putumana Somaya Karana Paddhati, which I just showed you, right? These are Karana texts. This helped in the Panchanga revival and sort of reconciliation a lot. Putumana Somayaji's Karana Paddhati. Then Shankaravarman Sadratnamala, all the way to Samanta Chandrasekhara Simha, who wrote the Siddhanta Darpana in 1835. This tradition was very, very much alive. Very wonderful text, Siddhanta Darpana, in which the nutations of moon, there's something called nutations of the moon. Even those are accounted into the calculations. See, the moon, as an object rotates, there is a small trepidation. There's a small shake, trepidation. Okay. That was observed and calculated by Chandrasekhara Samanta Simha. These are all kinds of the phenomenal things that people have done in this tradition. The reflection here is that in this very short glimpse with selective details, it is sufficient to know that we know nothing yet about ancient Indian knowledge traditions, especially astronomy. And indeed, to awaken ourselves for this to this tradition that has been spanning more than 3,500 years at least, would be such a great joy. And the knowledge of Nakshatra Vidya has certainly not disappeared over time. Having had in my younger ages, I used to feel that because of the colonial, so many colonial plundering, we have lost a lot of knowledge. Not at all the case. So many people have strived hard to keep up this knowledge traditions alive, and it is still deeply embedded in the fabric of Indian culture, right? For just a couple of months back, in a podcast, might be last year, right? In the last year, Deepavali was a little later because of the Adhika Masa phenomenon, right? So Kishore Biani, the founder of the Future Group companies, the Esther Future Group companies, was talking about consumer parameters to Nikhil Kamath in a podcast, talking about how this year consumerism changes, consumer patterns change because of the Adhika Masa in our calendar. So he, astute people know that all these affect businesses because we are still following these calendars, right? Still, Tuesdays are probably off working days or non-working days for barber shops in India. And the people know, that it's Tithi that will affect the flower market, Tithi that will affect the buying of jewelry in India. The entire the wedding industry in India is affected by that. So a lot of consumerism is affected still by the Indian calendrical system, which is a testament to the fact that we are still, it remains a living tradition in all of us. However, we will try to unravel and unearth. I've done a lot of sort of lecturing till now, but now let's move into a bit of the fascinating astronomical aspects. First is to understand the rotation of the Earth. Okay, first is to understand that it takes time, but before that, let us observe the sky. We know that the sun rises and sets, right? Where does the sun rise and set?
In our mind.
But when you observe the sky, it does happen, right? Let us not negate it per se, because when we see a beautiful sunrise, we do still see a beautiful sunrise. And so, which direction would that be?
Purva.
Yes, this is called Purva Dik, or the east side, right? Let's not debate that. It's not really east where sun rises. It rises at different points every day, and it sets in the west, we know. But where does the phenomenon of moon rise happen? In which direction does the moon rise and in which direction does the moon set? Namaste all. I know it's a slow morning somewhere there.
Does it change throughout the month?
It does change,
Ah,
but does a moon rise even happen in the first place?
It does.
Oh, I've heard of sunrise coffee. I've heard of Hyderabad sunrisers. Never heard of anything called the moonrise coffee yet. Mhm.
Moon
Moon
Moon,
is
is
a
always there.
reflection. Moon is a reflection, like of the light from the sun.
that is true, Ji.
So,
But
so
does it rise and set?
No,
no.
it's
Someone else had something to share.
A moon is constant, is always there. It doesn't rise or set.
Hmm. It doesn't rise or set.
It just rotates.
It just rotates. Okay. How about the stars? Do the stars rise and set?
It's the same like the moon. Stars are also constant.
Stars are constant.
no,
Anybody has any alternate ideas here?
no. Everything is moving. Sun is, Earth is moving. Also, Moon is moving. Other planets also moving.
Certainly. But do they rise and set for an observer? So, what's first thing we must understand? Beautiful statement in Indian astronomy. What is the center of the universe? Is the question asked in the Indian astronomy. What do you think could be the answer?
Bhagwan.
Sorry, Ji?
Bhagwan.
Bhagwan. Okay, that is an answer. Okay. In the Indian astronomy, you know what's the center of the universe? Yes, DCG. You were about to say. Sumeru. Okay. So the Indian astronomy says you are the center of the universe. Okay. In this ever expanding infinite universe, where is Bhagwan? Where is Sumeru? You are the center of the universe, is the answer. So this means that the Indian astronomy strived its best to make it relatable to you, to make the phenomenon relevant to you, where you are experiencing Prakriti as it is. So the observer-centric view was Pradhana. It is not that we do not want a heliocentric view. Let's try to understand this very clearly. It is that all calculations are observer-centric. So that to the observer here, to the time here, for doing the Dik, Desha, Kala, Nirnaya, the observations that we make must be very accurate. Okay. So hence, the observer's matha or the viewpoint is not neglected in the Indian. That's the center of the Indian tradition. Okay. So to better understand this, so I am going to shift my sharing to something else. Yeah, I'm sharing my entire screen. Is this visible for you all?
Yes, sure.
Yes.
So I'm facing the Dakshina Disha. So this, I have located myself in Parani right now, and the time is 6:12. Okay, in the east we see the night, coming up, preparing to come, and in the west the sun has just set. Okay, but what to do? Now we are gifted with a time machine. So let's go back a little in time, an hour, right? This was when the sun was slowly setting behind the horizon. Okay. Now, let us say I go towards my east, and then let us carefully observe the sky. Please tell me if the animation is clearly streaming for you. Now, I have slowly forwarded the time. Okay. Time is running here. Can you clearly see the eastern direction? What do you observe there?
Stars are becoming visible over the horizon.
Over the horizon. True. Did you just see the Saturn coming up?
Yes.
Now the Venus.
Yes.
Now the moon.
Now the
So
moon.
the moon just rise. And now Mercury and the sun. So the sun is rising, and so too all the celestial objects. If I forward a bit, okay, a lot of forwarding. So if you see, the entire celestial sphere is rising for us. Okay. The entire celestial sphere is rising for us in the eastern horizon. And when I go to the west, the entire celestial sphere is setting for me in the west. Then what is constant? Something here seems to be a little constant.
So that is the Dhruva Nakshatra.
That is the Dhruva Nakshatra. Everything else, other than the Dhruva Nakshatra and the circumpolar stars here for any location, everything else is rising and setting. Everything is rising and setting. Now, we have all studied the sun rises and sets due to the rotational motion. However, our education is so bad that we do not know if the moon rises and sets. We do not know if the stars rise and set. For IITians, it's a big awakening experience to know this, that everything rises and sets. So this is something, very interesting. Let us come.
I think this particular animation is an animation, no? This is a streaming, but of the sky, but it is just mind blowing actually. Because it puts into perspective the reality, right? I mean, we can always learn in words whether things rise or set and things like that, but to really see the North Star not moving, pole star, I think that itself is a huge this thing. We've been all told that the Dhruva Nakshatra is fixed in the sky for the observer, but this actually shows it in action.
Yes.
Really amazing. Yeah.
What's the elevation where you're at?
This is a free tool called the Stellarium. You may all download it and use it. Now let me come back to it, sharing my screen. So what we see is that we have studied in the schools that the phenomena of day and night is caused actually by the Earth's rotational motion, right? So this motion, how does it really affect us? Let us see with an analogy. Okay. So if you were to sit on a spinning chair and keep spinning this way, right, you are likely to see all the objects spinning the other way, correct? The direction in which you spin, all these objects, spin the other way. So you could see that in your vision, they are all moving in the opposite direction. Here, why do we say then the stars are all stationary, etc.? If you want to know this analogy helps us really get it. Okay. If you were sitting on a chair and spinning, okay, you're going to see all the objects, be it stationary or be it moving, actually rise and set. Am I right? If you are constantly spinning on this chair, even if your child was running from one place to another, even then in your vision, they will all go the other way. If they were stationary or moving objects, they will all go this way. So who is the first person to give this to us very in unequivocal terms? Aryabhata. Aryabhata says, Anuloma gatir naustaha pashyatyachalam vilomagam yadvat achalani bhani tadvat samapaschimagani lankayam udayastamaya nimittam nityam pravahena vayunakshiptaha lanka samapashimagaha bhapanjarasagraho bhamati. So owing to Sandhi, it becomes Lanka samapaschimago bhavanjarasagraho bramati. He says, Nausthaha, one who is situated on a boat. When you are on a boat and you are going in the Anuloma Gati, all the Achalam, Pashyati, Achalam in the Vilomagam, all the stationary objects on the bank seemingly look like they are going back. It's the modern day train analogy, right? We sit on the train and then say, Bangalore has arrived. We have arrived. But for our scenery, right? The scenery has changed. And it looks like all this has gone backwards and something has arrived. Like that, he's saying, Achalani bhani tadvat. Similarly, the unmoving bhani, bham, tara, Samapaschimagani Lankayam. He's saying that on the Lanka does not mean Sri Lanka. This is a technical term called Lanka in Indian astronomy. Lanka is where the equator and the prime meridian meet. Earlier, the prime meridian was the Ujjaini longitude, right? In the Indian tradition. What what callous Eurocentrism, huh? That these guys call it the Greenwich meridian, and then as if only in the 17th century somebody deduced a meridian, they name it after him, it goes through. What nonsense! Without the meridian, how would we ever do sea travel? And 10th century, we have had a phenomenal navy fleet. We have gone and conquered various nations on the sea. We have had sea travelers trading with so many people. Rome, we have had sea travelers, Kanha, help Vasco da Gama come here. What audacity these people have, huh? So they're calling it the Greenwich meridian. Okay. So in the Indian astronomical calculations, the meridian that passes through Ujjain, Mahakaleshwar temple, is the prime meridian for the earth. And in that prime meridian, on the point where the equator meet, such a point is called the Lanka. There he says, Samapaschimagani. They will all go very equally. We'll again go back to the visualization. We'll go to different spots and then we'll see. Udaya Hastamaya Nimittam Nityam Pravahena Vayuna Kshiptaha. So in the Indian tradition, we attribute a divine quality to everything. So the divine Devata who is responsible for the spinning motion is called Pravaha. He's a Marut. There are 52 Maruts. There are different classes of Devatas. Among them, Maruts is one class. And that's why Maruti is called, right? So Maruts are all Vayu Devatas. And then one is called Pravaha. That Devata is responsible for this spinning. And what uniform, beautiful motion, right? It's not like it's accelerating, decelerating, jumping, no, nothing like that, right? Beautiful uniform motion that it creates. That spinning, that divine entity who is the causal parameter for this is considered Pravaha. So this Pravaha Kshiptaha, propelled by this Pravaha Marut, Lanka Samapaschimagaha Bhapanjara Sagraho Brahmati, along with the Bhapanjara, along with the celestial sphere, along with the celestial dome. The Grahas also, along with the Grahas, they all go on this Brahmam. Brahmam, Gati is linear, is general motion. Brahmam is circular motion in Sanskrit. So they all are going in circular motion along with the celestial sphere. What is this Graha? We'll come to that in another session. So very, very fascinating. Why on earth Navagrahas? Very, very, very fascinating. We will come to that. But Bhapanjaraha Sagraho Brahmati. But he's saying Lankaha Samapaschimagaha. So what does that mean? Let us again shift our we'll go back to the presentation. So Tatra, see, first this is I'm currently in Palani in my worldview. Okay. If I were to bring myself down, I'm bringing myself close to the equator, let us say. Somehow this is not responding. Just give me a minute to manually convert this. So I brought myself to somehow 0 latitude, okay, very close to 0 latitude. Wherever I am on the longitude doesn't matter. Now let us again see this motion. Okay. Now you see the entire celestial sphere, there is no tilt to it the way it's rising. And you can't see the northern pole here. Right? The northern pole is on your horizon. So Lanka Samapaschimagaha. If you're not in Lanka, okay, if you're not in Lanka, then your sky will look different. Okay, let's go to Pune. Now I've gone to Pune. You see the slight angular difference in the way all the celestial objects are rising. And look at the polar star. Polaris is here. Right? Polaris is here and everything is rotating around it. Okay. What if I go even northern than that? My Polaris, you see, it has come up my sky. Okay. When I was on the horizon, when I was on the equator, my Polaris was on the horizon. In Pune, it was somewhere here. Now it has come all the way up here. Okay. Might be, let's go to where you are. Where would you be right now? Austin. Your pole star is somewhere, up here, and that tells you something. What did it tell you? What can you conclude out of this? Okay, some more experiments. Okay, let's put ourselves on the close to the North Pole. Now, where did the Polaris go? Polaris has gone all the way up here, right? Polaris has gone all the way up here. Now, what if I were to go way north? I've gone to 90-degree pole right now. Where is my Polaris? My Polaris is in my zenith. And how is the sun going? The sun is going all around where there is no rising and setting. Look at the knowledge that Aryabhatta has had. Where is the beautiful scientific description? He's saying that this rising and setting phenomenon will happen perfectly on the Lanka. What happens elsewhere? There is a beautiful later verse how to calculate your, depending on your desha. How do you calculate your Udaya time, Astamana time, etc. So now I am, on the 2nd of July. I have let the time run like this. From today, it has kept on running. And you see, it's right now, in July. Then what happens? Slowly, if I jump in July dates, it slowly is about to set. Right? September, on the equinoctial day, you will see that now the dusk has gone, and from the next few months, there is no sun to see slowly. Right? There's no sun to see. It's all night. Then slowly dawn comes, January, February. In March 21 or so is when in February 2 it's dark. March 21, 22 it slowly begins to dawn. And as the day goes, the sun comes up slowly in the That's why there is the Arctic and the Antarctic circles, right? So it is actually, why do these circle? What do they mean? What is the Tropic of Cancer, Capricorn? We will see after looking at the Rashi chakras and so on. However, it is important to appreciate that at different latitudes, at different longitudes, of course, your sky is different. The way you experience the sky is different. And especially this motion of rising and setting does not happen everywhere. Okay. So that's why Aryabhatta very clearly defines that the motion happens only the equal, the sama paschima gaha, the very symmetric movement, right, across the the westward movement happens only in Lanka. Even if it is in Parni, you will see a small tilt in the celestial arc. You see a tilt. There is a tilt to which the entire thing is going. Why? If you were on the equator, your Polaris was on the horizon, right? The more I go north, right? You will see every degree I rise, you will see the Polaris is rising. With my every northern increase in latitude degree, my Polaris is rising in the sky. So if you were wondering how did they find the lat long even in those days, it's simply by looking at the celestial configurations. Right? If you were on the equator, the Polaris is on your horizon. As you keep going north, it keeps shifting 1 degree, right? Slowly goes up all the way, right? Slowly keeps going all the way till you reach 90 degrees. In 90 degrees, it has reached your zenith. So on the North Pole, your pole star is right above your head, straight up above your head at the zenith. And the sun is just circling around you. And all celestial objects keep circling around you. So this is very precisely captured. Why? So hence, once you know your latitude, you can go northwards in the night and then see where to locate Polaris. Did that make sense for all? All is well? It's not swirling as it is? No. So that is why there is this technical term called the Lanka, okay, in the Indian. So we see that in the case of a rotating chair, the background is a frame of reference that helps discern the movement. Similarly, the observer's viewpoint on Earth, in order to track the motion of celestial bodies, we need a frame of reference, and that frame of reference is called the celestial sphere. Okay. So again, let's go back to the chair analogy. Okay. If you were spinning and if your child had moved from one point to another, do you believe you can discern that the child has moved when you're continuously spinning?
Yes, Ji.
How would you, G? How would you find it out?
Uh, unless the speed of my chair and the speed of the child is the same, I will be able to find out that the child is moving.
No, G. Even if the child is faster than the way in which you rotate the chair, it doesn't matter. You can still discern the child is moving. How? Because if you are rotating, okay, on the chair, you can see the background of the child during your first spin. During the first spin, you would have seen the child behind, the background of the child to be the door. By the time you have finished the spin, now you'll see that in the background of the child, some window is there.
Right.
And by the time you finish another spin, you will see a change and shift in the background of the child. Thereby, you will know that the child has been shifting spots. So that frame of reference is something that is relatively constant for you. And that which is relatively constant is called the celestial sphere or the Khagola. Kham means space, Gola means sphere. The celestial sphere. This Khagola, on the Khagola, we have conceived the concept of Khagola, on which different things can be put. All of a sudden ecliptic has come. I wanted to say the Khagola. Okay. So this Khagola also, I will later fully explain what are all the aspects in the Khagola. But as such, this rotational motion comes out of, and in rotational motion, you can discern the motion of other celestial bodies too. That has been our pursuit. Without all this stellarium, without all these tools, just by looking at sky, lot of dhyana, dharana, and by looking at the sky very carefully, observing the motions, calculating them. So what I wanted to say is that when you have a frame of reference, a sound frame of reference, you can build the positions of the various celestial bodies, for which the Rashi Chakra helps us. We will see about Rashi Chakra in the next session. But here we must first see that that the directions arise, the very dik, actually the ashta dik, they arise from the spin of the earth. The spin and the tilt of the earth caused many phenomena for us to observe on the earth. So these directions themselves are caused because of the spin. And even though we are in constant rotationary motion, we can discern the status of other objects provided we have a frame of reference. That is what I wanted to convey. Now, when we say north, when we say south, when we say west, east, it is to do with the spin of the earth, right? So the earth, right, is spinning on its axis, and that axis is given a notional north and a south points to it, and the direction towards which it is spinning is considered as, what is this direction towards which it is spinning? We see all the objects moving westward, right? So the entire earth is spinning eastward towards, so the west to east. So this anti-clockwise motion, which is basically the west to east. We have labeled one, our one arm. If you align your head towards north and lie down, your left arm will be the east and the right arm will be the west, and your foot will be the south. And then you can imagine yourself to be this ball of the earth that is spinning, and everything will be rising into your left and going towards your right, which means you are rotating from right to left. That is anti-clockwise. That is from west to east you are spinning eastward, and thereby everything is rising. In the Indian tradition, north is called Uttara Disha or Udichi. Similarly, east is called Purva or Prachi. West is called Paschima, Pratichi, Apara. East is also called Para. Then south is called Dakshina or Avachi. Then we have the intercardinal directions. The northeast direction is called Ishanya. The southeast is called Agneya. And the southwest is called Vayavya. And the northwest is called Nairitya. Okay. This is the Ishanya Mula, Agni Mula, Vayu Mula, right, Rakshasa Mula. All these, these form the foundations of our Vastu Vidya and architecture as well. So this, if you go around the place where we are in Palni, in Ivar Malai, if you go around, you will see that Ashtadik Linkas has been, Pratishtha of it has been done. We invite you to sometime come in your summer break here to the ashram. And we can see that we had to determine the perfect, to the center of the mountain, we had to determine the perfect 8 cardinal directions. It was a beautiful task given, and we had to achieve that. We had a lot of modern tools. Now, I wanted to also break this myth of magnetic compass. So how do you determine the direction? Today, what do you say? You determine the direction by using a magnetic compass, right? You look at east, west, north, south, west. Whereas the magnetic north and magnetic south are not the cardinal north and cardinal south, if you didn't know that. So they are not the cardinal directions. What did we do to find directions then? how are the Harappan civilizations are all perfectly, cardinal directions aligned in their construction and civil planning. It's because we had, since the Vedic times, we have had as the Shanku Sthapana Vidhi. So Shanku, today you can do this experiment, go back home and try this at home. Take a sharp pencil. Okay, take a sharp pencil, and if you have this pencil, take its height and then make twice that height as the radius of the circle, and then draw a circle around it, and keep this on a flat surface. Okay, so take a this is called a Shanku Sthapanam. This is Shanku is a sharp tipped metallic object, and this is usually of 12 angulas in height, and that twice, that is 24 angulas in radius, to draw a circle around it. Slowly in the morning, when the sun rises in the east, you'll see a long shadow. And as the sun comes up slowly, you will see the shadow slowly shortening, and at some point touching the tip of this circle that you have drawn. Mark that point. Okay. Then the rest of the day, you will see the shadow further shortening. Then it will start elongating the other side, right? It will grow at some point in time. At some point in time, it will touch the circle again mark that spot, right? Then it will exceed that and it will grow. You forget that, right? So you mark these points, and if you draw a straight line, that will be your perfect east-west line. See, east-west direction is a parallel line, right? You can draw as many parallel lines as this you want to. Parallel line that passes through the center of the circle also you want to, you can draw. A perpendicular bisector for this we can draw. I've already taught in the Sudbha Sutra class how the perpendicular bisector is drawn. So this gives the cardinal east-west direction, no matter where you are on Earth. Okay, no matter where you are on Earth, within the Arctic and Antarctic Circle region, wherever you have a sunrise phenomena and a sunset phenomena, you can use the Shankusthapana Vidhi to accurately compute your east, west, north, south directions. This you can, if you have a terrace, if you have a lawn where you have a flat surface, or you have a park nearby, you can always do this experiment and then figure out the direction. Many of them, when they think a stick sticking out, they think it's only time calculation, right? They think of it as the shadow-based time calculation. But this can tell you 100 things just out of Shanku Sthapana. The right angle triangle that a shadow forms, right? So there, if you can draw a right angle triangle here, joining the tip to this, right? This shows the angle, right, of incidence of the sun, right? And this will show simply this theta is enough for you to see. If you were to draw this shadow in a chaya, that's why Bhoot Chaya Vyavahara, even in Leelavati, is one among the chapters to do calculations. So this is how trigonometry is born, right? You see some celestial object in the sky. Now you have a right angle triangle, right? Now I want to know the arc length of this object. Is nothing but having known this value, I just have to find this arc length now. Having known this height already as 12 angulas and knowing the shadow, sine theta is nothing but opposite by hypotenuse. So measuring this, measuring that, this by this will give you sine theta value. Then there is something called Chapa Karma, which is sine inverse value. Using the sine tables you have, you can inverse and then find out what is this angle that this celestial object is there in the sky. It is incidenting on top of this tip and where the shadow is following. So this entire thing, right? This is all trigonometry. So that's how the trigonometry was plays a very important role when it comes to Indian astronomy. That's why they had to develop this domain quite very effectively. So this Shanku Sthapanam is simple. In a Samadhalam, they will ask. And that Samadhalam must be minimum 24 angulas. That is minimum twice the radius. Why? Because in some latitudes, If you are in a very small latitude, it can, in very vast latitudes, your shadow can actually not enter at all. It can go away if the circle is too small. Okay, without entering this itself, it can go in higher latitudes. Okay, so to avoid that, we do twice the height of this as the radius of this. Okay, this is the Shankusthapana Vidhi. It's a very beautiful activity that you can do with children. You need to have some observational patience and capacity. You should go, keep pulsating, keep checking out where the shadows, where it has gone in. You should know the moment of instance of it exiting the exiting the circle, and you should carefully connect and then draw these lines to get the perfect east-west direction. No matter where you are, this will work well for you. You will see that after that, if you do the compass-based checking also, you will find that this aligns well. Right. So very beautiful. Again, in Bhaskara 2 in Siddhanta Shiramani, he discusses this earth and desha. So I said dik, desha, kala, nirnaya. Right? Dik, we have seen that. Purva, Paschima, Uttara, Dakshina, 4 directions. And Ishanya, Agneya, Vayavya, and Nairutya. Ishanya, Agneya, Nairutya, and Vayavya if you go in the clockwise direction. Okay. So like that, there is this question, right? Today, even now, these flat earthers, this question is there, right? Very beautifully, you see, Bhaskara 2 in Siddhanta Shiramani, he says, Samo yatasyad paridhe shatam shaha prithvi cha prithvi nitaram taniyan narashta tat prishthagatasya gritsna sameva tasya pratibhatyasa. He says, so an infinitesimal part of the surface of the earth would indeed appear flat, right? And to a man standing on that, the whole world would give the illusion that it is flat, right? So all these are all good part of our astronomical texts, right? Dividing all this, helping us understand many of these facets, right? So this positioning ourselves, is the Desha Kala. So Desha, this Bhumadhya Rekha, equator was called Bhumadhya Rekha, right? And the longitude is called Deshantara. So when you find some computation somewhere, you will have to do Deshantara Samskara. Which means for your longitude, when will that happen? Because now you are celebrating New Year somewhere, then you need to do Deshantara Samskara to know when will come the moment when the other person can celebrate. So for example, if Bhagavan Shri Krishna was born in the midnight of the Krishna Ashtami, right, in the Rohini Nakshatra, right, if he was born in a particular tithi at that time, you should not celebrate in your own desha also at 12 o'clock in the night, right? So you need to know the moment that he was born elsewhere. So this is called Deshantara Samskara. So longitude means Deshantara. That's what you should know. Bhumadhya Rekha. Deshantara Samskara was well known in the Indian tradition. Similarly, Aksha is called latitude. Right? This is called Aksha, this is called Bhumadhya Rekha, and this is called Deshantara. All preceding, the very word terms, equator, longitude, latitude, etc. So as I said, in the ancient text, Ujjain was often used as the reference point for astronomical calculations. That's why the Mahakaleshwar temple there was the main point of the meridian for us. It's called the Ujjain meridian by many. This was similar to how we use the Greenwich meridian right now to standardize time and navigational coordinates. Similarly, the term Lanka in Indian astronomy does not refer to modern day Sri Lanka. Instead, it refers to the intersection between the equator and the prime meridian, right? And it's essentially the 0 point, 0, 0, right, in your graph chart. So there is this beautiful concept again. I'm just going because I'm just dealing with rotation. The rotation and the spin of the earth is causing all this, right? Without which it's a perfect ball. Where is latitude? Where is equator? The equator is the plane that is perpendicular to the axis of our rotation, right? So all these are phenomena. So the theme in which we are discussing all this is rotation of the earth. So the Savana Dina is another beautiful. We have the Aksha Dina and Savana Dina in the Indian tradition. There is a civil day. often the time between sunrise to the next sunrise. For us, a new day in the Indian calendrical system is born when the sun rises. So the interval between one sunrise to the next sunrise is about 24 hours. Hence, we should not think that the rotation period of the earth is 24 hours. That is a misconception. That is again something that we learn in the Western school, and we are happy with that east-west kind of thing. With this also, that earth's rotational period is 24 hours. Actually, Arkshadina, or the sidereal day, the star rise, the particular star to come to the same point in your celestial sphere, that time it takes is the Arkshadina, right? That is actually 23 hours, 56 minutes and 4 seconds. That is the actual time it takes for the earth to rotate 360 degrees. Why so? You see, if I am an observer on the earth, right? I am standing here as the observer on the earth. Okay. In my zenith, there is sun. So this is noon, 12 o'clock. This is okay for all. Can you imagine what I'm saying? You are on this plane on the earth and you are standing upright like this. Right? For you, the zenith, the sun will be in the zenith at afternoon 12. Okay? When the earth completes one rotation, you would have again come to the same point, but your sun would not have reached the zenith. Why? Because the earth has moved further in its orbit in this period. So it takes a little more rotation of the earth to bring the sun to your zenith. Are you following what I'm saying? This is very, very important concept. So I would have finished this 360 degrees, but as I moved along this arc, I need a little more time. So that is why for the sunrise to sunrise happening, it takes 24 hours. Okay, whereas the sidereal day, Arkshadina, look at all this that we have done in the Indian. How does it? Is it a granular equivalent to what we are studying right now in our schools or in physics with respect to astronomy? So this, for the same position for the observer, for sun to come back to the same position, it takes 24 hours. But for the star to come back to the same position, it takes 23 hours, 56 minutes and 4 seconds. That's called Arkshadina. This is called Savanadina. Ravehe Pratyak Brahmam Praguhu Savanakyam Dinam Drinam. All this, as I told you, everything is song, right? Ravehe Pratyak Brahmam Praguhu Savanakyam Dinam Drinam Akshab Mriksha Brahmam Tadvat Jyotisham Prerako Marut. So this Savanadina is the time taken for the sun to complete one westward revolution. Likewise, the Arkshadina is the time taken for the stars to complete one westward revolution. The impeller of these celestial objects is the Marut called Pravaha. Right? This is from Tantra Sangraha in 1500 CE. So this is the Desha. Right? So similarly, this visible dome, this is called the horizon, Kshitija, and this is called the zenith or Kamadhya for an observer. So observer-centric various observations have been made. Throughout all Itihasa Purana texts, you will see various observations made for that moment when a particular event is happening, allowing us to date back ideally to that situation. So this, is, I told you that observing the Dhruva Nakshatra, it helps us, understand our latitude, right? So we'll come to other things in the upcoming class, because if I open this, we'll go into revolution, and that will take us some more time to understand Shadritus and also understand the motion of the moon and so on. Let us continue that in the next. If there are any questions, anything to discuss, happy to address them. Namaste. Yes.
I did not understand the last part. In one frame, it is 24 hours. In the other frame, it is 23 hours and something. Can you please explain again?
This one, Ji.
And
so there are 2 days in the Indian tradition. One is called the Savanadina, which is considered the civil day, which is what we simply refer to as the day, in the Indian tradition. It means the time from one sunrise to the next sunrise. The mean period is actually 24 hours. The mean day's duration is 24 hours. However, there is something called Arkshadina in the Indian tradition. And this Arkshadina actually tells us the rotational period of the Earth. For the Earth to finish its rotation, it does not take 24 hours, but it takes only 23 hours, 56 minutes, and 4 seconds. See, in this entire 360-degree, right? When the star comes back to its same place, we have rotated and finished. But around the sun, we are also moving a bit. Thereby, if we had finished this rotation and we were standing straight again, then this white line and this line are parallel lines, right? But the sun would not have reached my zenith again. Zenith, horizon, it can reach anywhere in my observational dome. In this observational dome, sun, if it reaches here, it is the sun, rise time. I can calculate from here to here 24 hours. Or sun reaching the same spot here also means 24 hours, right? So when you see a star at your zenith, for it to reach back to this point in your zenith next day, it will actually take only 23 hours, 56 minutes, and 4 seconds. That is your actual Earth's rotationary period. But for the sun to come back to the same zenith point, it takes 24 hours. Why? Every day, we are moving almost about a degree along our circular path. And for the Earth, for the observer to align, for the head to align directly to the sun, there are about a degree, right? Almost a degree we have traversed here. So for this degree to get traversed a bit more, okay, it takes a little more time. So the Indian tradition has something called Savana Dina and Arksha Dina. I didn't really want to do this, but I'm just saying that we have observed our rotationary motion to such accuracies. That is what I wanted to say.
So I have a question, Ji.
Please.
So this is a little bit more history related. We've been reading in some places that there has been a lot of exchange between the Greek and the Egyptian astronomical traditions and Bharatiya traditions. Is there a historical basis for that, or is it just some hypothesis?
No, it is there. Yavana Jataka is there. Yavanas, Greeks were called Yavanas, and we have had a text called the Yavana Jataka, which tells what the Yavana, how do Yavanas compute, what is their horoscope like, what are their calculations like. So that is there. There has been active knowledge exchange here. Just like now, the world was always there even before internet well connected.
Mm-hmm.
So Maya, that yes, of course, internet connects us faster, but that doesn't mean there was no knowledge exchange. There was active exchange around the globe, active knowledge of civilizations around the world, better understanding. It's only when civilizations came to rewrite narratives, there was a challenge, right? Where they have tried to successfully rewrite a particular centric narrative.
Mm-hmm.
Without that, there was always active exchange. Very interesting fact is the Rashis, right? There are different objects that are denoting different Rashis, different star constellations.
Mm-hmm.
In fact, the research scholar that I work with in New Zealand, she was saying that there are no Sarpas in New Zealand, but the Maori tribe still used to call a particular constellation which is connected to a Sarpa as Sarpa only. So she was saying that there could have been some universal transfer of knowledge in many places. Consolidation could have happened. Like today, conferences could have happened, knowledge could have been disseminated. That could have been one of the important dharmas at some point in time as well.
So the concept of attributing objects or animals to Rashis, or even the days of the week, all this stuff existed across different cultures in parallel.
Difference, of course, yes. The math behind them we will see in the coming classes to the extent possible.
Okay.
Also the Rashis, we'll see about them all in the coming classes. But of course, there seems to have been a very active knowledge exchange and a sort of an understanding.
Okay.
Maybe end it here, and We'll continue in the next session. Astronomy classes can typically be overwhelming, sometimes eye-opening, sometimes what's happening on a Saturday morning in this world. But do hang on. There are many layers that we are going to slowly unravel, and so much so that at least after we do Rashi Chakra, let's at least see how the Kundli works for all of us. Okay.
Yes.
Let's do that in the upcoming sessions.
Om Sarve Bhavantu Sukhinah, Sarve Santu Niramayah, Sarve Bhadrani Pashyantu, Ma Kaschid Dukkha Bhag Bhavet. Om Shanti Shanti Shanti. Harihi Om Shri Gurubhyo Namaha. Harihi Om. Thank you, Ji. Thank you, everyone, for joining this morning.
Thank you.
Thank you, Ji. Namaste.
Namaste. Namaste.
Thank you. Namaste.